What we saw in the last video was we figured out the recurrence relation for our code that solved the Fibonacci problem. And so in this video we're going to look at the unrolling method, which was the same method that we used to solve the factorial runtime or the factorial recurrence relation. The unrolling method, some people might call it the tree method. And what this method is, again, is we're going to start with just a tree with just one node in it. That node being t of n, no branches, nothing else. And we're just going to repeatedly apply our recurrence relation until we get a pattern, or until we start to see a pattern emerge. So t of n is exactly equal to t of n minus 1 plus t of n minus 2 plus O of 1. And so one thing I'm going to do differently from last time, or at least one thing I'm going to do differently from when we did the unrolling for factorial, is I'm just going to rewrite these differently. It's still going to represent the same exact information, but I'm just going to write these like this with an O of 1 here. We're actually going to draw branches now. T of n minus 2. So these branches represent a plus sign. We're still adding here. We're still applying this definition. These branches are going to just represent a addition sign. And we're going to still apply our recurrence relation, but now we're going to apply it in two places. We're going to apply it here and we're going to apply it here. And so let's look at this t of n minus 1 first. T of n minus 1, well, let's plug in n minus 1 for n here and see what we get. Well, if we plug in n minus 1 for n here, we're going to get n minus 2 and n minus 3 here. And also this O of 1. And so much like this step, we're going to just copy this and say that that is equivalent to O of 1 here, plus a t of n minus 2, plus a t of n minus 3. And we do the same thing over here. If we plug in n minus 2 here, we're going to get an O of 1 from here, a t of n minus 3 here, and then a t of n minus 4 here. And if we did that one more time, I might run out of space here. Start here. O of 1 here, O of 1 here, O of 1 here. And now we apply this recurrence relation to these four t's over here. So t of n minus 2 is going to become O of 1. We're going to get t of n minus 3, t of n minus 4. This guy is going to become O of 1 plus t of n minus 4 plus t of n minus 5. Let's see if I can fit this here. This t of n minus 3 is going to become t of n minus 4 plus t of n minus 5. And this guy is going to become an O of 1 plus a t of n minus 5 plus a t of n minus 6. So what I'm actually going to do, I'm just going to start. I'm just going to redraw what we had up here just so it's cleaner. We had an O1. So what you might see again is that all the values in these nodes are O1. Alright, and so we're just going to be ending up adding up a bunch of O1s like we did last time with factorial, except now there's just a lot more, right? This is actually again, just copying what we had here. T of n minus 3, T of n minus 4, T of n minus 4, T of n minus 5, T of n minus, what was it? 4, T of n minus 5, T of n minus 5, T of n minus 6. We're going to look at the pattern in the next video.